In this video, we're going to be focusing solely on the concept of average rate of change. And this is a huge concept for us to grasp before we can move on to calculus concepts. Okay, so it's really a simple concept at its root. It looks very sophisticated when you're looking at everything that I have on the screen right now, but it's really, really simplistic overall. So here, let's focus on the graph, the picture in the top right. So I have a function f, and it's kind of hard to tell, but it's this guy, kind of like a parabola. Okay, and I'm picking out two random points on this parabola, right? So I have one point whose x coordinate is a, its y coordinate would be f of a, and I have a second point whose x coordinate is b and whose y coordinate is f of b. And what I'm doing is I'm finding the average rate of change of the function from point A to point B. Okay, and I have a formula that I use for it. All right. Now, first of all, notice notation here. Average rate of change is given by this notation, delta y over delta x. And anytime you see a delta in mathematics, that typically represents the concept of change. So delta y is like the change of y, delta x is the change of x. So really what we're doing here is we're trying to measure the change of the y values from point to point divided by the change of x values from point to point. And next to it, you have the formula for average rate of change. F of B subtracted by F of A over B minus A. Okay, let me simplify that for you, and hopefully this will really make sense for you. Instead of using A and B here for a moment, let's treat the points like this. Okay, I'm going to call that point. Let's do it as x sub 1, y sub 1, and then this point as x sub 2, y sub 2. Okay, so if we go back to this fancy formula, f of b is the same thing as y sub 2, and f of a is the same thing as y sub 1. So we're doing y sub 2 minus y sub 1. B is the same thing as x sub 2, and A is the same thing as x sub 1. So we're doing x sub 2 minus x sub 1. All right, so hopefully it's jumping out at you. That should look really familiar to you. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. What's that the formula for? That's the formula for slope between 2 points on a line. Okay. So really, that's just showing me that average rate of change is nothing more than the measure of the slope of the line that's passing through these 2 points, right? These 2 points are being connected with this line right here. And the average rate of change is nothing more than the slope of that line, okay? Now, why do we have a different name for it than slope? Why is it now referred to as average rate of change? Well, because we're not working with a linear function anymore. We're working, in this case, with a quadratic function, and the average rate of change will be different for that function depending on what 2 points you pick, okay? So let's visualize this a little bit more with a GeoGebra illustration, okay? And in this particular illustration, I have a square root function, which is clearly not linear, okay? And I have 2 points, A and B, already picked out. A is the point -6, -1. B is the point 2, 5. And you're going to notice, as I slide here, I'm going to come up with the horizontal and vertical distances from point A to point B. The horizontal distance is 8 units, the vertical distance is 6 units, and now it's going to go through the formula for average rate of change on this function from point A to point B. So there's your formula, f of b minus f of a over b minus a. In this case, based on these 2 points, that would be the same as f of 2 subtracted by f of negative 6 divided by 2 minus negative 6. Well, f of 2 is the y-coordinate of b, which in this case is 5. F of negative 6 is the y-coordinate of a, which is negative 1. So if I did 5 minus negative 1 over 2 minus negative 6, notice I end up with 6 over 8, or 3/4, 0.75, 75 hundredths. Okay, so that's just showing me that from point A to point B, the change from one coordinate to the next is roughly 3/4 of a unit. Okay. Now notice if I move either point A or point B, that number for the average rate of change is going to change. It's going to be different. Right? So if I move point B outward, I no longer have the same average rate of change. Okay, it's actually getting a little smaller in value. That's because the steepness of the line that's passing through points A and points B is getting less steep. Okay, now if I bring these closer, now that line's getting a little steeper, so you can see that the average rate of change is increasing. Okay. All right, let's go back and look at an example ourselves. Okay, so here in our example, we're working with the function f of x equals 3x squared minus 2x plus 3. So that's the parabola that you see graphed in blue. And we'd like to find the average rate of change of f from negative 2 to 1. Okay, now it's important to understand that when we say from negative 2 to 1, we are referring to these as x values. Okay, so what we need to do first in order to utilize the formula for average rate of change is we need to evaluate the function f at both negative 2 and at 1, which we can do that algebraically. We can plug negative 2 in for x, we can plug 1 in for x, and we can see what the y's are. Or in this case, we have the graph in front of us. So I'm just going to kind of cheat here, and I'm going to say that f of negative 2 is equal to 19, and f of 1 is equal to 4. Okay, so now I have everything that I need to utilize the formula here. The change of y over the change of x, so delta y over delta x, is equal to one y coordinate subtracted by the other divided by one x coordinate subtracted by the other. And that ends up giving me 15 over negative 3, which is equal to negative 5. So the average rate of change on this function from negative 2 to 1 is negative 5. We're saying that the points between negative 2 and 1, they're changing on average by a rate of negative 5 units for y to 1 unit for x. Okay? All right, click out of your writing tool, hit the word done, and then you're going to move over to practice 4. And I just want you to take a minute. You're going to try this one on your own, the Khan Academy practice on average rate of change, and it will let you know if you're doing things correctly or not.